Okay, so welcome to part 2 of this presentation. We were just looking at part B, what proportion of entering customers receive service from B. So I'll go back to that bit. My video recorder, my camera, it just lagged out. So we get this final answer. Right, so that's our final answer for part B. Okay, so let's have a look at part C. Part C is pretty easy. So what is the average number of customers in the system? So pretty much it's the long run number of customers in the system. So we're figuring out the expected value of the number of customers that will be in the system over time. So let's have a look. So all we're going to do is we're going to multiply the respective number of customers for each state. So if you look at state A and B, they can only have one customer one person in the system in that state, right? So we'll be timesing 1 by pi A, 1 by pi B. This one here, we have, for state AB, we have 2 customers, so we're timesing pi AB by 2. So that's our answer for part C. Okay, part D is interesting. So let's go back to it. So it says, what is the average amount of time that an entering customer spends in the system? Okay. So all we have to do is we have to just let W be the expected time a customer spends in the system, and we use this formula. So W equals EL on our estimated value of lambda, right? And to estimate that value, all we're figuring out is the long run rate, essentially. So it will just be lambda times the long run proportion of customers who enter the system. And W would just equal that. So we're substituting in what we got from part C. So EL is what we obtained in part C. And we put it in there and we get this final answer. And that's the end of my presentation. Thank you for listening. See ya.